Good morning to all of you. In previous sessions, we have seen how to identify convolution by using different methods, that is, using graphical method, tabular method, matrix method, and mathematical method. In today's session, we will be discussing properties of convolution. Okay. So today we will be discussing three properties of convolution. So first one is commutative, second one is associative, third one is distributive. So the convolution operation is basically denoted as y of n is equals to x of n convolved with h of n. Okay. So if I want to write down the formula for this x of n convolved with h of n, then it can be represented as summation k is equals to minus infinity to infinity x of k into h of n minus k, correct? Or it can be represented as y of n is equals to h of n into x of n. So here h of n is convolved with x of n. So I can write down this formula as again k is equals to minus infinity to infinity h of k into x of n minus k. Okay. So you see these two forms of this convolution, right? Here the convolution operator is star. Okay. So you should not use this dot operator to indicate the convolution operation. The convolution operation is denoted by using this star operator, okay, where x of n is convolved with h of n or h of n is convolved with x of n. Okay, it will produce same result. The difference between these two is here the impulse response h of k or h of n is folded and shifted, but in this case the input sequence is folded and shifted, correct? So this is how the convolution operation is represented. Okay. That is x of n convolved with h of n or h of n convolved with x of n. Okay. So the first property of the convolution is commutative. Okay. So as per commutative property, as we have seen in the previous slide, x of n convolved with h of n is same as h of n convolved with x of n. Okay, so this is the commutative property. So if I want to represent this property in block diagram form, then on the left hand side I am applying x of n to the given system. Okay, so this block represents the discrete time system. In discrete time system, the x of n is getting convolved with h of n, okay, to produce the output y of n. Right? This y of n is nothing but x of n convolved with h of n, which is same as, or which is, you can say, equivalent to the right hand side of the equation, where h of n is applied to the system, and this again block represents the discrete time system, in which this h of n is getting convolved with the x of n again to produce the output y of n. Okay. So this is as per the commutative property or commutative law. Okay. So this is nothing but the interpretation of your commutative law. Okay. So our commutative property. The second property is the associative. Okay. So in case of associative property, if you are convolving x of n with convolution of impulse responses h1 of n, h2 of n is same as convolution of x of n with h1 of n, and the resulting convolution is convolved with h2 of n. Okay. This is nothing but the associative law or associative property. Okay. So if I want to represent this in block diagram form, then this can be represented as what here I am applying x of n to the system. Okay, first block represent the discrete time system which convolves this x of n with h1 of n, right? Then the result is getting again convolved with h2 of n, produce the result y of n or output y of n, and this is same as, so basically this block represent this right hand side of the equation. Okay, where initially x of n is getting convolved with h1 of n, right, and then the result is getting convolved with h2 of n. Okay, so basically this can be considered as two different linear time invariant system in cascade form. Okay, so these two systems. This is the first one in which your x of n is getting convolved with h1 of n, and in second the result produced by this system is getting convolved with h2 of n. Okay, so these two systems are connected in series, okay, or cascade form, right? So this is equivalent to, if I want to plot or represent this left hand side of the equation, so this can be represented as, here I am applying x of n, okay, to the given system. Okay, and system is basically computing or convolving this x of n with the convolution of h1 of n and h2 of n. Okay, so within system already the convolution of h1 of n and h2 of n is performed, and then it is getting convolved with x of n, okay, to produce the output y of n. Okay. So this is as per the what associative property. So here the two systems are connected in cascade form. Okay, so again as per the commutative property, you can interchange the role of this h2 of n and h1 of n. Okay, that means this operation is same as x of n h1 of convolved with h1 of n, then the result is convolved with h2 of n. So this is same as what, x of n convolved with h2 of n, then convolved with h1 of n, as per commutative property that we have seen in the previous slide. As per associative property, here what you are doing, you are initially convolving x of n with h1 of n, then the result is getting convolved with h2 of n. Okay, it is same as convolving x of n with the convolution of h1 of n and h2 of n. Okay, so this is as per the associative property, right? So let's solve one example here, right? So you have provided with two impulse responses, okay, that is h1 of n and h2 of n. Okay, and you have to determine the impulse response of the cascade of two linear time invariant systems. Okay, having these impulse responses. Okay, so the overall response we have to identify. Okay. The cascade of means basically uh, you will be taking the cascade of this system, that is first system will be producing the impulse response, that is nothing but this first system is producing the impulse response h1 of n, and which is then applied to the system with impulse response h2 of n. Okay, can view this as it is, as this thing, or you can say that we are applying to the system, okay, the del 1 of n. Okay, that is nothing but unit sample sequence which produce the impulse response h1 of n, okay, which then applied to the another system which produce the convolution of h1 of n with h2 of n. Okay. So you have to identify the impulse response of this overall system, okay, which will produce the convolution of h1 of n and h2 of n. Right? Here what has been asked, so here you have to determine the overall impulse response, okay, of the cascade of two LTI system with individual impulse response. The first system impulse response is h1 of n, and second system impulse response is h2 of n. So it will be convolving this h1 of n with h2 of n. Okay. So how you will be solving it? Okay, so by using this formula, that is nothing but the convolution formula, to determine the overall impulse response, okay, of two LTI systems in cascade form, will simply convolve h1 of n, the given h1 of n and h2 of n. Okay. So this can be represented as h of n is equals to h1 of n convolved with h2 of n, right? So as per the convolution formula, so it can be written as summation k is equals to minus infinity to infinity h1 of k into h2 of n minus k. Okay, so that is the convolution formula, right? So we'll be using this convolution formula to identify the overall impulse response of the system, that is nothing but h of n. Okay. So I can rewrite this formula here. Okay. So which formula I am using? That is h of n is equals to summation k is equals to minus infinity to infinity h1 of k into h2 of n minus k. So you are provided with h of n. H of n is given as 1 by 2 raised to the power n u of n, 1 by 2 raised to the power n into u of n, right? And is nothing but h1 of n. Okay, so h2 of n is given as h2 of n is 1 by 4 raised to the power n u of n. Okay, 1 by 4 raised to the power n u of n, that is nothing but h2 of n. So I'll substitute these values in this convolution formula simply by replacing this variable n by k. Okay, so in place of n I will be substituting k and n minus k. So this can be written as summation k is equals to minus infinity to infinity, but you will be writing 1 by 2 raised to the power k into u of k in place of h1 of k, right? This is your h1 of k, and in place of h2 of n minus k you can write 1 by 4 raised to the power n minus k, right, into u of n minus k. Okay, so this is nothing but your overall impulse response. Okay, here I can modify the limits of this summation. Instead of minus infinity to infinity, I can start it from 0. Okay, because you know that this u of n or this u of k is nothing but the unit step sequence. Okay, so as per the definition of this unit step sequence, this unit step sequence will exist. Okay, it will be 1 for n greater than or equals to 0, and for negative values of n it is 0. Okay, for n less than 0 it is 0. Right. So I can eliminate the negative values of k from this summation, so I can start it from 0. Okay, instead of minus infinity I can start it from 0. Okay, so here 1 by 2 raised to the power k will be as it is, and for the values of k which are greater than or equals to 0, this u of k is 1, right? So there is no need to write on this u of k now, okay, because this will be 1 itself, and 1 multiplied by this 1 by 2 raised to the power k will be 1 by 2 raised to the power k itself. The second term, that is 1 by 4, so 1 by 4 raised to the power n minus k, this will exist, okay, up to the value of k is equals to n only. Okay, so again, if we are substituting value of k greater than n, okay, so what does it means? If you are substituting value of k greater than n, so the just for example, if I am substituting the value of k is equals to 0, so this will be simply n minus 0, right? The next one, that means it will be simply n. Okay, so that will be u of n will be there, right, if I am substituting k is equals to 0, right? Similarly, if I am substituting k is equals to 1, as I have started it from k is equals to 0, right? So if I am substituting k is equals to 0, it will be u of n, right? If I am substituting k is equals to 1, right, so it will be what, n minus 1. If I am substituting k is equals to n, so it will be n minus n. Okay, n minus n means it will be simply u of 0, right? And u of 0 is 1, right? Here I have substituted k is equals to n, so u of 0 is 1. But if I am substituting the value of k greater than n here, so what will happen? So it will be u of n minus, I am substituting the value of k here greater than n will be n plus 1. Okay. If I am substituting k is equals to n, so it will be n minus n, so it will be u of 0. But if I am substituting k is equals to n plus 1, okay, this value will be obviously greater than n because I am incrementing n by 1. Okay, so what will happen? So it will be u of minus 1, because this n minus n will be 0, minus 1 will be, okay, so u of minus 1, and u of minus 1 is 0. That means if I am substituting the value of k greater than n, so this term, that is u of n minus k, will be 0, right? If you substitute what, if you are substituting it as u of n minus n plus 2, okay, which will be greater than n plus 1, so again it will be u of minus 2, so u of minus 2 is again 0, right? So for the values of k greater than n, okay, so it will be simply 0, right? So therefore I can restrict these limits of summation, instead of varying from minus infinity to infinity, I can take it from k is equals to 0 to n. Okay, instead of 0 to infinity, I have taken it from 0 to n because of this second term. Okay, so this u of k will be 1 for these values. Similarly, the second term I can write here by 4 n minus k, right? Again, this u of n minus k will be 1 for these values of k, right? Okay, so after this, I can see here the summation variable is k here, so I can take this n outside of this summation, because in this case summation variable is k. So if I'm taking 1 by 4 raised to the power n outside of this summation, then within summation I will get k is equals to 0 to n. 1 by 2 raised to the power k will be as it is. Okay, but I have taken 1 by 4 raised to the power n out of summation, so the remaining term will be 1 by 4 raised to the power minus k, right? So in here I can rewrite it as 1 by 4 raised to the power n summation k is equals to 0 to n. So this can be written as 1 by 2 raised to the power k. Okay, so 1 by 4 raised to the power minus k means simply it can be written as 4 raised to the power k. I can take it as 4 inverse raised to the power minus k is nothing but 4 raised to the power k, right? Then if I multiply these two terms, 1 by 2 raised to the power k into 4 raised to the power k, it would be 2 raised to the power k, right? So I can again rewrite it as 1 by 4 raised to the power n summation k is equals to 0 to n. 1 by 2 raised to the power k multiplied by 4 raised to the power k will be 2 raised to the power k, right? So as per the mathematical series, I can indicate this overall impulse response h of n as 1 by 4 raised to the power n. So this is the standard mathematical series. K is equals to 0 to n. 2 raised to the power k can be represented as what? 2 raised to the power n plus 1 minus 1. Okay, so this will be the overall impulse response, that is h of n, correct? So again, this 1 by 4 raised to the power n is kept as it is in this case, and this mathematical series k raised to power 0 to k is equals to summation k is equals to 0 to n. 2 raised to power k can be represented as 2 raised to the power n plus 1 minus 1. Okay, so it will produce same result. Whatever values you are substituting for k in this case, it will substitute it will produce the same result depending on how many values are there for k. Okay, from 0 to n, okay, depending on the maximum value of n. Okay. So this is the required overall impulse response of the system, right? So here you identified it by using this convolution formula, that is h1 of n convolved with h2 of n by taking the cascade of it. Okay, you have connected these two systems in series, right? So you use the convolution of k is equals to minus infinity to infinity h1 of k into h2 of n minus k, and then by substituting the values of h1 of k and h2 of k in this convolution formula, and then modifying the limits of summation by replacing this u of k and u of n minus k with value 1. Okay, because for remaining values of k, these values will be 0, right? For negative values of k, here this u of k will be 0, and for the values greater than n, okay, for k, this u of n minus k will be 0. So according to that, you have modified these limits. Instead of taking it from minus infinity to infinity, you are taking it from 0 to n, and then by simple mathematical adjustment you have identified h of n, final h of n. Okay, so we have seen first property, that is nothing but commutative. Second one associative. Okay, the third property is the distributive. Okay, so as per distributive property, if you are taking the or convolving x of n with h1 of n plus h2 of n, this is same as convolution of h1, sorry, x of n with h1 of n plus convolution of x of n with h2 of n. Okay, so this is as per the distributive property. Okay, so there are two variety system with impulse responses h1 of n and h2 of n, right? Then this can be excited by the input x of n. Okay, so the sum of two responses is identical to the response of an overall system, right? So this can be again represented by using block diagram, right? So left hand side I can represent here it as, so to the system I am applying x of n. Okay, so inside system this convolution operation will be performed. Okay, convolution of x of n with the addition of this h1 of n plus h2 of n. Okay, so this addition is there inside the system, and in the system this x of n is getting convolved with this addition result to produce the output y of n. Okay, so this is the left hand side of this equation, and this right hand side of the equation can be represented as x of n is applied to the system. Okay, so this x of n is getting convolved with h1 of n. Okay, this first term is getting convolved with h1 of n. Similarly, it is getting convolved with h2 of n. Okay, and finally, whatever the results which are produced by these two LTI systems are getting added here. Okay, you are adding this result to produce y of n. Right? So x of n convolved with h1 of n. So this will be the output here, that is x of n convolved with h1 of n. Here output will be x of n convolved with h2 of n, right? So here output is x of n convolved with h2 of n, and here output is x of n convolved with h1 of n. Okay, so these two results are getting added here. So here you can observe that these two systems are connected in parallel. Okay, as per the associative property, these two systems are connected in series or cascade form, and as per the distributive property, these two systems are connected in parallel. Okay, so these two will be same. Okay, that is x of n convolved with h1 of n plus x of n convolved with h2 of n is same as x of n convolved with the addition of these two impulse responses, right? So this is nothing but the distributive property. Okay, so in today's session we discuss three properties of convolution. First one is commutative, right, where x of n convolved with h of n is same as h of n convolved with x of n. Okay, it is x of n convolved with h of n is same as h of n convolved with x of n. Okay, this is a commutative property. As per associative property, x of n convolved with the convolution result of h1 of n and h2 of n is same as x of n convolved with h of n and then convolving it with the H2 of n. Okay, so that is associative property. We have seen one example. Then we have seen the distributive property, in which x of n convolved with the addition of h1 of n and h2 of n is same as x of n convolved with h of n plus x of n convolved with h2 of n as per distributive property. So in next session we'll be discussing causal linear time invariant systems, or the causality of LTI system, how to identify the causality of LTI system, or how to define the causality of an LTI system. Okay, so that will be discussing in the next session. So thank you for joining this session.